Hey, have you ever stopped to wonder how one AI model, like GPT, can just write a whole essay? Well, another one, like BERT, can understand the tiniest little details in a question you ask it. It feels like magic, right? Well, it's not. Turns out, it all comes down to a really powerful but actually pretty simple idea. So, let's get into it.
I mean, it's a huge question, right? How can this one family of AI master not just language, but vision and even audio? We're talking translating, coding, analyzing pictures, the whole shebang. It seems like it should be impossibly complex, but the real secret, the key, is all in how they're put together. And that's really the big reveal here. The answer isn't some kind of crazy magic. It's just smart engineering. Underneath all that complexity are just two core building blocks. That's it, just two. And you just snap them together in different ways to get these incredible results. Seriously, think of them like Lego bricks for building AI. All right, so let's meet our two Lego bricks. Now, the official names are the encoder and the decoder, which sounds a little technical. But for our purposes, it's way easier to just think of them as the reader and the writer. It perfectly describes what they do. So let's look at what they do. First up, the encoder, our reader. Its whole job is to understand. It takes in a whole chunk of information, like an entire paragraph, and just soaks it all in to get the full context, the full meaning. Then you have the decoder, our writer. It does the exact opposite. Its job is to create new stuff, one little piece at a time. It's always just trying to predict the very next word. So it's super simple. One reads, one writes. Okay, so let's start with that first block. What happens when you build an AI using only the reader? Well, you get a specialist, a master of understanding. And the superstar of this category is definitely BERT. You've probably heard of it. BERT's superpower is that it can look at a sentence from all directions at the same time. It doesn't just read left to right, it looks at the words that come before and after a word to figure out exactly what it means. It's got this complete 360-degree view of the context. So how in the world does it learn to do that? Well, it plays this really clever game during its training. It's called masked language modeling. Basically, you just take a sentence, you cover up a random word, you mask it, and then you tell the model, all right, figure out what's missing. Yeah, it's literally a high-tech game of fill in the blanks. The model has to use all the other words in the sentence, the whole context, as clues to make its guess. And when you make it do this millions, even billions of times, it gets ridiculously good at understanding how words relate to each other. And all of this leads to the big payoff, right? This deep, deep understanding is what makes these reader models, these encoder models, so perfect for things like analysis. We're talking text classification, figuring out sentiment, like is this review good or bad, or even digging through a huge document to find the one specific answer to your question. If you need to understand something, this is your guy. All right, that's the reader. Now let's switch gears and look at our second building block. What if you build a model using only the writer? Well, then you get the creators.
And I think you know the most famous one here, GPT. Now, GPT is the polar opposite of BERT. It's not built to analyze stuff that's already there. Nope. Its entire reason for existing is to generate brand new text, completely from scratch.
And it learns how to do this with a totally different training method. This one's called causal language modeling, and it's actually way more straightforward. The model is only allowed to look at the words that came before it, strictly left to right. That's it. And its only job, its only goal is to guess the very next word. You can think of it as autocomplete on steroids. You know, when your phone tries to guess the next word you're going to type, it's exactly that, but on a massive scale. It's constantly just predicting what comes next, what comes next. And by doing that over and over again, it learns the rhythm and patterns of human language, turning it into this incredible text generator.
And that right there perfectly explains why these writer models, these decoder models, are the powerhouses behind things like chatbots, creative writing tools, and even code generation. I mean, anytime you need an AI to create a new string of words based on a starting prompt, this is the architecture you want.
Okay, so we've got the reader and we've got the writer. The obvious next question is, what happens when you stick them both together? Well, you get a powerful hybrid. An architecture that's designed for tasks that need to both understand something deeply and create something new.
And these are models like BART and T5. They're built for what we call sequence-to-sequence jobs. Here's how it works. First, the encoder part, the reader, takes in an input, let's say a sentence in French, and it works to fully understand it. Then it passes that deep understanding, that meaning, over to the decoder part, the writer, which then uses it as a guide to generate a completely new output, like that same sentence, but now in English. So if you lay it all out, it becomes crystal clear. You've got this beautiful division of labor. You have the encoder-only models like BERT, which are all about understanding. You have the decoder-only models like GPT, which are built for creating. And then you have the hybrids, the encoder-decoders like T5, which are perfect for converting information from one form into another. It really is all about picking the right Lego brick for the job. And that's exactly why these hybrids are the absolute go-to for things like machine translation, going from one language to another, or for text summarization, where you have to first understand a long article before you can create a short summary. It needs both skills. Okay, but this is where things get really wild. These two simple building blocks, the reader and the writer, they're so fundamental, so versatile, that we're now using them in areas that have absolutely nothing to do with text. Case in point, the Vision Transformer, or VIT for short. This model takes the exact same reader architecture that we saw in BERT, but instead of reading a sentence, it reads a picture.
So how does that even work? It's just brilliant. First, it takes an image and chops it up into a grid of little square patches. Then, and this is the key part, it just lines those patches up in a row, treating them like a sequence of words in a sentence. And finally, it feeds that sequence into a totally standard transformer encoder, our good old reader, which just processes it to understand what's in the image. It's basically teaching the AI to read a picture.
And that really is the central idea here. The key to understanding modern AI isn't trying to memorize every new model that comes out. That's impossible. It's about seeing the pattern. It's about knowing the building blocks. Do you need a reader, a writer, or both? Because at the end of the day, the architecture is everything. It's what defines what the AI can and can't do.
So that leaves us with a pretty mind-blowing question, doesn't it? We've figured out this blueprint, this set of universal building blocks for intelligence that works on text, on images, on audio, you name it. The blueprint is here. So, what are we going to build with it next?